Alright, in this video I discuss process capability. What do I mean by the process capability? Definition is the ability of a process to meet the design specification for a particular service or a product. So in this case, design specification has two things. One is the nominal value and the tolerance. The nominal value is a value that is targeted by a process. A tolerance is an allowance given. An example of how design specification works. I'm supposed to make 25-ounce water bottle. So the nominal value in this case is 25 ounce. I give myself a tolerance when I produce this water bottle. So I cannot go below 20 ounce, and that is my lower specification. Obviously, I cannot fill water anything less than 25 ounce and sell at the price of 25 ounce. Right? So I'm vulnerable to the lawsuits. So I have to be reasonable in setting the lower specification limit. On the other hand, I set 30 ounce as my upper specification. I cannot afford to fill in more water and sell it at the price of 25 ounce. So in this case, I'm vulnerable to the profit losses. Again, I have to be reasonable in setting the upper specification limit. So the distance between the lower and upper specification is called design specification width. Next up, let us take a look at how my process is capable of producing 25-ounce water bottles. So I collect data from process outputs, basically lots and lots of water bottles, and I plot the weight of those water bottles, and I come up with the process distribution. Right? It looks something like this. Let us say the mean of this process distribution is 25 ounce. Great. And let us say 32 ounce is 3 standard deviations to the right of the mean, and 18 ounce is 3 standard deviations to the left of the mean. So why do I pick 3 standard deviations? Because that is the standard practice used when the process capability is measured. In other words, capability question becomes, is your process capable of producing 99.73% of its products within the design specification limits? Let us see how we can answer that question. To do that, let us superimpose what we saw earlier. One is the design specification, another one is the process distribution. Okay, this is my design specification width of 10 ounces from 20 to 30, and this is my process distribution where the extreme points are 3 standard deviations away from mean to my left and right. So 99.73% of products will fall between 18 and 32 ounces. So as you can see, some of those products will fall beyond the design specification width. So this is indicated by the orange shaded areas on both sides. And these products are defective because they don't fall within the design specification width. Clearly, this process is not capable of producing products because not all of 99.73% of products fall within the design specification limits. Now, the question is, how can we quantify this process capability idea, right? So it is by comparing two measures. One, design width, and the other one is to compare the Six Sigma distance. So the process capability is a ratio of design width and Six Sigma distance. So let us plug in some values and calculate process capability. Let us plug in some values and calculate process capability. The design specification width, which is nothing but the upper specification minus the lower specification, and the Six Sigma distance. In this case, it's given by 32 minus 18. So it is 10 over 14, and CP is 0.71. So since CP is less than 1, the process is not capable. Right? So with this example, we put some number to the process capability. So when Six Sigma distance, right? So this is your Six Sigma distance is wider than the design specification width, the process is not capable. So how can we make the Six Sigma distance less wider than the design specification? By driving out the variability that exists in the system, right? So that's your design specification width. And in other words, by reducing the sigma. So if you reduce the sigma drastically, even the extreme points, right, three standard deviations away from the mean, those two extreme points are within the design specification limit. So this is the basic idea of the Six Sigma philosophy, right? So driving out the variability, right? So in this case, clearly the process is capable of, and as a result, CP will be higher than 1. Key question is the process capability equation is still valid when the mean of the process distribution and the center of the design specification width is not aligned? Short answer is no. So let us take a simple example. So in this case, 6 sigma distance is contained within the design width, so the process is capable. Let's take a look at what happens if the process distribution is shifted to right. So that is the direction of the shift. Distribution is shifting. The shaded region in yellow indicates the products that will fall beyond the design specification width. But if you use the process capability formula, CP, you will get a value higher than 1, which is not correct in this case. So somehow we have to modify the formula such that the shift in the mean is taken into account. So this new formula is called process capability index. Basically, I'm going to split the design specification width into two pieces, right? Upper specification minus lower specification. So that is this width, right? And the other one is mean minus lower specification. Depending on the shift, one of these pieces will increase or decrease. For instance, since the shift of the mean is towards right, the upper specification will decrease. This is smaller. On the other hand, if the shift is to the left, the mean minus lower specification will decrease. Now use these two design widths, right, and compare them with 3 sigma limits individually. Right? That is the idea of process capability index. And if you look at 6 sigma distance, actually 6 sigma distance represents 99.73% of the products. That is, half of those products will fall to the left, right? And the other half will fall to the right of the mean, right? So in this case, we will compare one design width, right, to the left of the mean, in this case 3 sigma, and the other design width with the 3 sigma distance to the right of the mean. If either one of the ratios are less than 1, right, you know the process is not capable. So to ensure that, we simply take minimum of these two ratios. And that is the formula for process capability index. Let us take a look at the illustration with numbers in it, right? So first let us calculate mean minus lower specification, right? In this case, it's 28 is the mean, minus 20 is your lower specification, divided by your 3 sigma is given by this distance, 28 minus 21. Let's take a look at upper specification minus mean. Upper specification is 30, minus mean is 28. And this 3 sigma is basically 35 minus 28. So the first ratio is 8/7, and the second ratio is 2/7. So this first ratio is greater than 1. This one is less than 1. Since the second ratio is less than 1, the process is not capable. If you want to summarize process capability and the process capability index, it's the following. CPK can be used in any situation because it is more general as it takes the shift in the distribution mean into account. CP can only be used when the mean of process distribution and the center of the design specification are aligned. So that's the end of the video. Hope you guys enjoyed the video, and thank you.